Okay, I'm just going to start with a quick review from the note I created in the previous lesson. We talked about when do we get a point of discontinuity and when do we get a vertical asymptote. You see how we have the factor of x minus 2 in the denominator? It does not simplify with the numerator, so that becomes a vertical asymptote. But in the second example, you see that we have this factor here simplifies with this factor here, so we end up with an equation like that. When these two factors simplify, that's what creates a point of discontinuity. So let's take a look here. Consider the function. It appears, not true, but it appears that the graph of this function will have a vertical asymptote at x is equal to 2 because of the non-permissible value. But that's not true. Something different happens, and that's where we're going to talk about point of discontinuity. So factor and simplify. I'm going to take this, and I'm going to factor the top, and then complete the equation. And if we look carefully, we see that these two factors simplify. So I have the simplified function of f at x is equal to x plus 1. Well, if we graph that thing, we know it's linear. You can put it into your graphing calculator, or if you're good with lines, I know the y-intercept is 1, and it has a slope of 1. It would be a line that would look like this. But we talked about it earlier. I have a non-permissible value here, and I know that x cannot equal 2. So on this graph, where x is 2, this point can't exist, and that's where we talk about a point of discontinuity. So what are the coordinates of that point? I can take a look. Looking at the graph, it is at 2 and 3. So what that turns into, I'm going to wipe out that point right now, and I'm going to put it back in as an open circle. So if I connect these points, this is what the graph is going to look like. It's going to be a line that approaches that hole, and then it continues out the other side. Because we know algebraically and graphically, they got to send the same message, where x cannot equal 2. So that's where it turns into a hole. But I want to talk about how we get that point of discontinuity. If I take a look at this simplified function in equation form, if I sub in the value, the non-permissible value here of 2, I find that I get y is equal to 3. So there's your algebraic way of finding the point of discontinuity. And if we look, here's the point of discontinuity, and that's consistent with what we see on the graph. Okay, compare the graphs of the functions f at x and g at x. What are my non-permissible values? Well, I know that x plus 1 cannot equal 0, so I know that x cannot equal negative 1. And that's the same with g at x. The feature at the non-permissible value. Well, this is where we're going to have to go ahead and factor this guy. So if I factor that, I end up with, I'll just do that up here. I'd end up with x plus 3 times x plus 1 all over x plus 1. And if I go ahead and factor g at x, that's going to give me x minus 3 times x minus 1 all over x plus 1. As we can see with the function f at x, these two cancel. So the feature at the non-permissible value is a point of discontinuity. Because the factor cancels out. But if I take a look at g at x, There's no factors that cancel out here. So what we have is, we can call it a vertical asymptote. So I'm going to let you go ahead and graph those two. First, let me help you find the point of discontinuity. So my simplified function here is f at x is equal to x plus 3. So if I write that as an equation, I get it that way. Now I'm going to put in my non-permissible value generated by that factor that canceled out. So I'm going to end up with y is equal to negative 1 plus 3. So y is equal to 2. So my point of discontinuity is going to be at negative 1 and 2. So I'll just graph that with the open hole. And here we have a vertical asymptote, go back to pink, and that happens at x is equal to negative 1. And as a dotted line, there's my asymptote. And if we think about our rules, I'm going to let you determine what those graphs look like. And I'll give you a moment to do that, and you can check your solutions on the answer key.